Well, hello C++ programmers and fellow game developers. Brian Malloy here, and this little talk is going to be about how to make stars smart. I'm not sure that makes any sense. I should make the aliens smart, and so this is kind of backwards. You might need a little help from your friends for this to make sense, but the idea is still the same. In fact, I would like to redo this with making the alien dodge the stars instead of the stars dodging the alien. But that's what's happening. The stars are dodging this little alien. And so I'll show you the code for how it does that. But what you can basically see is we have this star background. It's not scrolling or anything. I'm keeping it simple. The alien is going to wrap around, so the alien leaves one side and comes back the other, and then the stars are going to stay on the screen. But when the alien gets within a certain distance of them, they're going to react and try to get away. And of course, since they cannot leave the boundary of this box, they do get stuck and they get into this jitter mode, at which point you could probably do whatever you wanted. I don't know, but the idea is I'm trying to show you how you can incorporate some AI into your video game. So there's the idea. So just remember that the stars stay within the background that I'm drawing, and the alien wraps around, and then we've got this star background. Okay, so we've got that. Let's take a look at a class diagram for this. So what have I got? Well, it's not the whole animation. It's just the sprite part of it. So what I have is a base class, MySprite, that's purely virtual. It's an abstract base class. The pure virtual functions are getSprite and update, because the actual sprite is probably going to be down here. And so if I want to, and I'm going to have a polymorphic list of MySprite. I'll show you that. And in that polymorphic list, I'm going to put a bunch of stars and one alien. I'm sorry, let me take that back. I'm going to have a bunch of smart stars and one alien. So the alien will be in the 0th location, or the first location in the list. I think it's a list. And the smart stars are going to be in the rest of the list. And so why do I have the base class? I have the base class so that I can build a polymorphic list and just run through it and draw it and update it. So what's going to be different about these sprites is the update. So in this update, actually, the alien wraps around. So the update function, which I didn't put it here, did I? I didn't actually. Oh, because it's there. I did write an update for alien, but I just didn't put it here. It looks like Alan, but I think it's alien. I don't know. Anyway, let me just. You know what? I'll add it now. Does that say alien? For operations, I do have update. Let me put an update. So the name is update. The type is void, and the parameter is dt, and it is a float. There we go. Okay, so there it is. Now we're happy because we've got update in there. So I do overload the update. I have to, or I can't instantiate the alien. And let's see what else. And this update just allows this alien to scroll around, to wrap around. The stars, on the other hand, there's no update here either. Let me just stick it in there. Let me put a new one here. So we want a new operation called update. It is a void, and we wanted to have one parameter. It is called dt, and it's a float. Okay, I should have called it virtual, and I didn't. Oh well. Anyway. So I have to have the update, so there's the update, and I have a getSprite for both of them. I have to have both of those. And then I have a smart sprite, which does have the update. I did make sure to get that one in there. And actually, this update uses that update to stay within the boundary of the, the square bounding box. So this update keeps the star within that box. This update does the AI, the dodging. So I'm actually using it in there. Let's look at Smart Sprite. That's Smart Star. That's probably the only one you're really interested in. So let's iconify this. Let me show you the main program. So it's actually it's actually called bouncingstar.cpp, and I guess I just want to show you, maybe I'll show you the .h2. How much room do we have? Let's see. Okay, so here is the, I guess what I want to show you is, it's a vector. I should have used a list, I guess, but I'm not deleting or anything, so what the heck. Anyway, I've got a vector of my sprite star like I told you. It is a polymorphic collection because I have different types of things in there. Two types, actually. Let's see where I do that. So I put first I stick a yellow alien in there. So here I'm making the alien. Notice the parameters I pass to the constructor. The prefix for the file name, the suffix, because they could change, the number of frames, and the starting point where I wanted to start off. And I wanted the alien to be over on I didn't want it to be in the middle because the yellow stars all start in the middle. So here I'm identifying the middle of the screen. Here I'm creating a smart star, passing the whole file name because it's not going to use a plist. And then I push back these stars, and I put in max stars, which max stars is 20, so I've got 21 items in this vector. Okay, so that's the polymorphic vector, and then I schedule the update right here, and we update them all, and since we use add child, they're put in the scene graph, and they'll automatically be drawn in the order that I put them in, by the way. So the alien will get drawn first, and the stars will go in front of that. Okay, let's take a look at star, just for the heck of it, so you can see. Star derives from my sprite, like I said, as I showed you in the UML class diagram. Here are the things I have for star, but I think the thing you really want to look at is this guy right here. So let me see if I can, oh gosh, I lost it. I'll go get it. Here it is. Let me go stretch this guy and just show you. Here's smart star. I'll split it into smartstar.h so you can see what's up here. Up here I've got the enemy. Now there are two things we need to do. The two things are we need to know where the enemy is so we can avoid the dude. So if we find out that the enemy is close to us, how close? Well, within 150 pixels. If it gets that close, I got to evade. Okay, and actually, by the way, imitation is the highest form of compliment that mediocrity can pay to genius. And I got to tell you, I got a lot of this code from a student in our class who I thought did a real nice job. I didn't change it much at all. Yes, I didn't change it much at all. So we can take a look at it. So what have I got here? I've got the enemy, and I passed the enemy in. I don't know if you noticed that. Let me just see if I can show you here. So if I let me just go ahead and go in there. Yeah, let me go in here. And what you'll see is that I create the alien, it's right there, and I pass it in when I make a, a star, a yellow star. I pass to the constructor the file name, the point of origin where I want it to spawn, and this enemy. So there are three parameters. Let me just show you here. So the file name, the point at which I want it to spawn, and the enemy. So let's get rid of this. We get that now. Okay, and it needs to know where the enemy is so it can evade. So here we go. First of all, I get my position. And I compute an increment. Why am I doing that? Oh, yeah, I am incrementing here. And in the above class, in star, I just keep it on the board. So I incremented here. It was just easier for me to do that. And then I set its new position, okay, wherever it is. Then I get, this is my location, then I get the enemy's location, and then I compute this Boolean. Do I need to evade? And this is basically kind of a version of the distance formula. I explained to you once, at one point, that it's inefficient to take the square root. So what I'm doing here is I'm doing everything except taking the square root of both sides. So I'm just making sure that the x1 minus x2 squared plus y1 minus y2 squared is less than the distance between them squared. Okay, and if I take the square root, I'll get the distance between them, but I don't need that. I just want to know if this is less than this. If this amount is less than that amount, I want to evade. Now, if I want to evade, I simply want to check. Am I to the right of the enemy? If I'm to the right of the enemy and my velocity is, let's see, if I'm to the right and my velocity is negative, that is, I'm going to the left, then I want to change my velocity and change my direction. Okay? So, actually, these are stars and it doesn't matter. I don't know if you can see them change direction because maybe they'll they're kind of rotating. They might rotate the other way. We might want to see if we can spot that. And here's the other one. And notice now we look at the y's. If my y is greater than the other guy's y, or if my y is less than the other guy's y, wait a minute. Let me redo this. So if my y, if I'm above the other guy, and my direction is such that I'm moving downward, then I want to change directions. That's what this says. Okay, so this evades pretty simple. It's not the best. You can make it more robust if you like. But basically, so let me come back up here. What I'm saying is, if my x location is to the right of the enemy and my velocity is negative, which means I'm going left, that means I'm going toward the bad guy. In that case, I want to change my velocity and, of course, change my scale so I'm facing the other way. Or if my x is to the left of the other guy, but I'm going to the right. I hope that makes sense to you, because remember, if my velocity is positive, I'm going to the right. If my velocity is negative, I'm going to the left. So if I'm to the left of the enemy and I'm going left, I got a problem. That's basically what this is saying. And so this will move me into evade mode, and this will simply keep me on the board. So that's why I have both of those. That's the idea with this. Not real complicated, and you can see it running. You'll see it working. You could change it, maybe make it more robust if you like, but you can see that it works. So essentially, if I'm above or to the right and headed toward them, you can see they change directions. Let me see if we can see they also rotate the other way. They should. Yeah. Oh, it doesn't seem to. Maybe I'm wrong. I don't know. It did for a little bit, and then it went back to non-evade mode, I guess. I don't know. Anyway, that's the idea. I hope this helps. Happy programming. Brian Malloy, over and out.